today we are going to discuss wrapping and trigonometric functions. After watching this video lesson, you should be able to identify the coordinates of points in a unit circle using the wrapping function by using the special angles as reference angles. And also you're going to identify the 6 trigonometric functions using the unit circle. Using this unit circle here, which is centered at the origin and has a radius of 1 unit, we can illustrate a positive real axis if we're going to wrap this counterclockwise from this origin 1, 0. So from here, moving counterclockwise, we are to describe a positive real axis. And if we're going to wrap it clockwise po, we can have a negative real axis. And we are to illustrate this on our next slide. And in this unit circle, we have these circular points within this unit circle po. And these points are paired with x and y coordinates po. We can see in the given figures here on this slide that we can still measure the distances and locate the points on the number line in the unit circle by wrapping the number line around the circle po. As illustrated po here sa first. The positive part of this number line, as illustrated in this figure at the middle, will be wrapped in a counterclockwise direction around the circumference of the circle. And in the figure at the right po, the negative part of the number line is shown as it is wrapped around the circumference of the unit circle in a clockwise direction. Note that the number line is infinitely long and thus it will be wrapped around the circle infinitely many times. As a result, infinitely many different numbers from the number line get wrapped to the same point on the unit circle. Let us start by finding the circumference of the unit circle. We know that the unit circle has a radius of 1, therefore, its circumference is equal to 2 pi. If we're going to wrap the numbers 0, 2 pi, negative 2 pi, and 4 pi, it is wrapped in a positive x-axis at the point 1, 0. If we're going to wrap the number pi over 2, which is 1/4 of the circumference of this unit circle, it is wrapped to the point 0, 1, which is at the positive y-axis. If we're going to wrap the number pi, it is at the negative x-axis to the point negative 1, 0. Since this is 1/2 of the entire circumference of the unit circle. And the number 3 pi is wrapped to the point 0, negative 1, which is at the negative y-axis. And we know that this number is 3/4 of the circumference of the circle. Let's have this following example. We are going to find the coordinates of the following circular points. Letter A, W at negative pi over 2. Letter B, W at 5 pi over 2. This figure will help us to determine the coordinates of the following circular points. For letter A, we are to wrap clockwise, and we know that pi over 2 is equal to 1/4 of the circumference of the circle. Therefore, negative pi over 2 is here po. And its coordinates is 0, negative 1. For letter B, 5 pi over 2 exceeds 2 pi. And if we're going to subtract 5 pi over 2 to 2 pi, the difference is pi over 2. And we know that pi over 2 is here and its coordinates is 0, 1. So yan po. Let us have more examples and we are going to find also the coordinates of the given circular points. We have points W at negative pi and W at 3 pi. Negative pi is wrapped clockwise since it is negative. And pi is equal to 1/2 of the circumference. Therefore, it is also here at positive pi. So, its coordinates is negative 1, 0. For letter B, we're going to find the coordinates of 3 pi, and the circumference of this unit circle is equal to 2 pi, and 3 pi is pi greater than 2 pi. So 3 pi is here also, and its coordinates is negative 1, 0. In this slide, we're going to find the coordinates of the special angles such as 45 degree, 60 degrees, and 30 degrees angles. Let us first have this 45-degree angle, and we know that in a 45, 45, 90 triangle, the side opposite 45 degrees is equal to x, and the side opposite 90 degrees is equal to x square root of 2. And the side opposite the 90 degrees, so ito po yun, since ito po yung 90 degrees, serves as the hypotenuse of the right triangle. And we're going to find the length of the legs or the congruent sides by equating x square root of 2 to 1. Then, solving for x, we are to divide both sides by square root of 2. X, since cancel na po yung square root of 2, is equal to 1 over square root of 2. Or, we can have square root of 1 half. Since the square root of 1 is 1, and the square root of 2 is same lang po since irrational po siya. But, we can rationalize po this value by multiplying square root of 2 both in the numerator and denominator parts. X is equal to 1 times the square root of 2 is the square root of 2 over square root of 2 times the square root of 2 is the square root of 4. And square root of 4 is 2. Thus, this square root of 1 half is equal to square root of 2 over 2. Same with this side po. Its length is equal to square root of 2 over 2. Therefore, the coordinates of this 45-degree angle within this unit circle is square root of 2 over 2 and square root of 2 over 2. Since this represents the x and this represents the y. For this 60-degree angle po, we have this side as the hypotenuse since it is opposite the 90-degree angle and its length is equal to 1. Since this is the radius of the circle or the unit circle. And in 30, 60, 90 triangle, the relationship of the sides, opposite 30-degree angle is x, opposite 60 degrees is x square root of 3. So we're going to multiply the length of the side opposite 30 degrees by square root of 3. And the length of the hypotenuse, which is opposite of the 90-degree angle, is equal to 2x. We're going to multiply twice the length of the side opposite 30 degrees. Since the length of the hypotenuse is 1, we can find the length of the side opposite 30 degrees, which is equal to 1 half. Since 2x is equal to 1 and x is equal to 1 over 2. And the side opposite 60 degrees will be equal to 1 half times square root of 3 or square root of 3 over 2. And this is also equal to square root of 3 over 4. The coordinates of the 60-degree angle is 1 half and square root of 3 over 2. Since this is the value of x and this is the value of y po. The vertical line represents the y and the horizontal represents the x. For the 30 degrees, the value of x and y are swapped. Therefore, if we have 30-degree angle po, the coordinates is square root of 3 over 2, 1 half. Let us summarize the coordinates of the special angles that we have. 30 degrees, 45 degrees, 60 degrees. Let us first have this equilateral triangle here. We know that each angle of an equilateral triangle is equal to 60 degrees. And since this positive x-axis is an angle bisector of this angle, we can say that this angle is equal to 30 degrees. And we know that the radius of this unit circle is equal to 1. Therefore, each side of this equilateral triangle is equal to 1. Since this side is bisected by the positive x-axis, therefore, this length is equal to 1/2, which represents the value of y. So, doon po, nakuha natin yung values na square root of 3 over 2 and 1/2. For the 45-degree angle po, its coordinates is square root of 2 over 2 and square root of 2 over 2. For 60 degrees, we are going to swap the coordinates of the 30-degree angle. And from that po, we have the coordinates 1/2 and square root of 3 over 2 for 60 degrees po. Let's have coterminal angle. Two angles in standard position are coterminal if their sides coincide. Ang tinutukoy po ditong sides ay yung terminal sides and they must share the same position po. Let's have this example. We are to find one positive angle that is coterminal with 60 degrees in standard position. Since yung 60 degrees po ay nasa first quadrant, so nandito po siya, 60 degrees. And if we're going to find one positive angle, we have one complete revolution until ma-reach po yung 60 degrees. So, mahanap lang po natin yon if we're going to add 360 and the sum is equal to 420 degrees. And this 420 degrees is the smallest positive angle that is coterminal with 60 degrees po. Example 2, we're going to find two positive angles that are coterminal with negative 30. Negative 30 or the terminal side of negative 30 is in quadrant 4. So, nandito po yung kanyang terminal side. And kapag hanapin po natin yung positive angle po na coterminal from this point, so we're going to move counterclockwise until we reach this terminal side po. And this terminal side is equivalent to 330 degrees. Since if we're going to subtract 30 degrees from 360 degrees, the difference is 330. And to find another positive angle, we are to add 360 to 330. And this angle is equivalent to 690 degrees po. Let's have example 3. We're going to find one negative coterminal of 30 degrees. The terminal side of 30 degrees falls at quadrant 1. Since we are looking for a negative coterminal angle, we're going to start from this point, moving clockwise po until we reach this terminal side po. And since one complete revolution is equal to 360, we're going to subtract 360 from 30 degrees para makuha natin yung negative coterminal angle. And the angle coterminal to 30 degrees is negative 330 degrees. So, ito po ay negative 330. Let's have number 4. We're going to find an angle with measure between 0 degrees to 360 degrees that is coterminal with an angle measures of 1,290 degrees in standard position. Since ang hinahanap po natin dito is coterminal angle and yung atin pong hanapin dito is positive coterminal. Since positive po yung ating hanaping coterminal angle, we're going to subtract multiple of 360 before 1,290 degrees. And the multiple of 360 that is lower than 1,290 degrees is 1,080. And if we're going to subtract 1,080 from 1,290, the difference is 210. And this 210 is an angle that is coterminal with 1,290 degrees po. Let's have this example. We're going to find a positive and a negative angle that is coterminal to an angle that is pi over 6 radians. This given angle is in radian measure. Therefore, instead of adding 360 degrees to find a positive coterminal angle, we will be using 2 pi. Therefore, pi over 6 plus 2 pi is equal to 13 pi over 6. Since 2 pi is equal to 12 pi over 6, to find a negative coterminal angle, we're going to subtract 2 pi from the given angle since it does not exceed to 2 pi. Therefore, the negative coterminal of pi over 6 is equal to negative 11 pi over 6. These are the points to remember. Two angles in standard position are coterminal if their sides coincide or if their terminal side share in the same position. To find the positive coterminals of an angle, we simply add multiples of 360 degrees if the given angle is in degree measure, or multiples of 2 pi if it is in radian form. To find negative coterminals, we simply subtract multiples of 360 if the angle is given in degrees, or multiples of 2 pi if it is in radian measure. Let's discuss the 6 trigonometric functions. And I know that you are already familiar with the acronym SO, Ka, To, Wa. We have the sine, the cosine, and the tangent of an angle. And the sine is equal to the opposite side over the hypotenuse. In this given figure, the sine of this angle is equal to A over C, or the opposite side over the hypotenuse of this given triangle. For the cosine of A, so let's have this angle A, it is equal to the adjacent side, which is the value of B, over the hypotenuse C. For the tangent, we have the opposite side of angle A. So let's have this angle. And its opposite side is A over the adjacent side B. And these three functions can be used to find the value of the other three functions. For cosecant A, this is the reciprocal of sine A. And since sine A, or the value of the sine of an angle, is equal to the opposite over the hypotenuse, then its cosecant is equal to the hypotenuse over the opposite side. Then, for the secant of an angle, this is equal to the reciprocal of cosine A. And since cosine A is equal to the adjacent over the hypotenuse, then the secant of an angle is equal to the hypotenuse C over the adjacent side B, if we are referring to angle A po. And for cotangent A, this is the reciprocal of tangent. Since tangent A is equal to opposite over the adjacent side, this means that cotangent of an angle is equal to adjacent side over the opposite side. So, wag po tayong malilito sa ating mga given letters. Just memorize this acronym po to help you determine the value of the 6 trigonometric functions. Let's have this example. Let P is equal to the coordinates negative 3, negative 4. Be a point on the terminal side of theta. Find the 6 trigonometric functions of theta. So, from here po, we are to draw the terminal side with this point, negative 3, negative 4. Since x is equal to negative 3 and y is equal to negative 4, we're going to find the value of r. Apply the Pythagorean theorem. Since we are looking for the length of r that represents the radius of the circle. Since r is equal to the square root of x squared plus y squared, we have r is equal to square root of the quantity of negative 3 squared for x plus the quantity of negative 4 squared for y is equal to negative 3 squared, or the quantity of negative 3 squared is equal to 9, plus the quantity of negative 4 squared is equal to 16. So 9 plus 16 is equal to 25. And square root of 25 is 5. Note that the value of r is always positive. Since we already know the values of x, y, and r, we can now find the 6 trigonometric functions of theta. Remember that sine theta is equal to y over r. Then, it is equal to negative 4 over 5. And cosecant theta is reciprocal of sine theta. Therefore, its value is negative 5 over 4. For cosine theta, its equivalent is x over r. Therefore, its value is equal to negative 3 over 5. And for second theta, which is reciprocal of cosine theta, so we're going to take the reciprocal of negative 3 over 5, then it is equal to negative 5 over 3 po. For tangent theta, this is equivalent to the value of y over x, and the value of y is negative 4 over the value of x, which is equal to negative 3. Therefore, its value is equal to 4 over 3. And cotangent theta is the reciprocal of tangent theta. Therefore, cotangent theta is equal to 3 over 4 po. For example 2, we are going to find the value of tangent 90 degrees and cotangent 90 degrees. Let's use this figure here. The terminal side of 90-degree angle intersects the unit circle at the point 0, 1. So ito po, 90 degrees at point 0, 1 po. To find the tangent of 90 degrees, since tangent theta is equal to y over x, and the value of y in this coordinate is 1, over the value of x is 0. Therefore, the value of tangent 90 degrees is 1 over 0 or undefined po. For the cotangent of 90 degrees, which is equal to the reciprocal of tangent theta or tangent of 90 degrees, and the value of x is 0 over the value of y, which is equal to 1. Therefore, the value of cotangent 90 degrees is equal to 0. In evaluating trigonometric functions, it is very important to know the signs of each trigonometric function. So, kailangan po nating i-consider din po yung ating signs. The illustration on the next slide will help you remember which trigonometric function is positive in each quadrant. In this figure here, this shows which trigonometric function is positive in each quadrant, which is highlighted in green po, or nakabox po siya ng green. And we can remember these rules by using the acronym ASTC, or All Students Take Calculus. For the first quadrant, the 6 trigonometric functions are positive. So, all. For the second quadrant, so ito po, second quadrant, the value of sine and its reciprocal or the cosecant is positive po. For the third quadrant, the positive functions are the tangent and the cotangent po. So ito po. For the fourth quadrant, the positive functions are the cosine and its reciprocal, the secant function. We have here the reference angle po. And let A be a non-acute angle in standard position that lies in a quadrant po. Its reference angle is the positive angle denoted by AR formed by the terminal side of angle A and the XR. To find the reference angle, we need to locate the angle, kung ano po yung quadrant niya, or kung saan po yung kanyang terminal side. And we have this formula po. If the terminal side of angle A lies in the first quadrant, this is always equal to the angle measured. So, ang ating angle po dito is positive angle. For the second quadrant, to find the reference angle, we need to subtract the given angle from 180 degrees. Or if the given is in radian measure, we are to subtract the given radian measure to pi. If the given angle is in the third quadrant, we need to subtract 180 from the given measure. Or if it is in radian form, we need to subtract pi from the given angle measure. For if the terminal side of an angle is in quadrant 4, we need to subtract the given angle from 360 if the given angle is in degree measure, or subtract the given angle from 2 pi if it is in radian measure. In particular, reference angles are never negative. A reference angle can be 0 if the original angle's terminal point lies on the x-axis po. Kung given naman po ay negative angle, we need to find its positive coterminal angle po. But these rules or formulas will help you to find the reference angle of a negative angle. A negative angle measured in degrees. If the terminal side of the given angle is in quadrant 1, we need to add the negative angle to 360 degrees. So, for example, we have negative 330 here since this is coterminal to 30 degrees. And since it is in quadrant 1, we need to add negative 330 to 360. And its sum is equal to positive 30 degrees po. Also shows that it is coterminal with 30 degrees. So, pwede pong ganun po yung ating paghanap ng reference angle kapag negative po. In quadrant 2, negative times the negative angle minus 180 degrees po. If the terminal side of a negative angle is in quadrant 3, we are going to add that angle to 180 degrees. And if it is in quadrant 4, we need to multiply negative 1 to find its reference angle po. For a negative angle measured in radians, we are to replace 360 degrees by 2 pi and 180 degrees by pi po. So, ayan po, pi, 2 pi, pi. The same with the formulas if the given angle is measured in degrees po. Let's have these following examples. We need to find the reference angle of the given angle measured in degrees, measured in radian. Since kapag wala pong degrees na symbol here, ibig sabihin po, nasa radian measure po yung ating given angle. And for letter C, we have a negative angle po. Let's have letter A. Since 300 degrees or its terminal side lies in quadrant 4, we are going to illustrate 300 here. So from here, so the angle is 300 degrees. And the angle it makes with the x-axis is equal to, so ito po yung angle na hinahanap. We are going to subtract 300 from 360. And its difference is equal to 60 degrees. For letter B, the given angle measure is in radian measure po. Since the given angle has no degree sign po. And 2.3 lies between pi over 2, which is approximately equal to 1.5708, and pi, which is approximately equal to 3.1416. And the terminal side of this angle lies in quadrant 2, and its reference angle is equal to or approximately equal to 0.8416 since we're going to subtract 2.3 from pi po. Since ito po yung ating formula if the given angle or the terminal side of the given angle is in quadrant 2 po. For letter C, the given angle is a negative angle po. And here po, ang ginawa po is hinanap po yung positive coterminal niya. And if we're going to illustrate negative 135 in a coordinate plane po, its terminal side lies in quadrant 3 po. And its positive coterminal is equal to 225. Since if we are going to add 225 plus 135, the sum is equal to 360 degrees. And since the terminal side of this angle is in quadrant 3 po, we are to use this formula, 225, the positive coterminal, minus 180 is equal to 45 degrees. Or if we're going to use the formula that I mentioned earlier po, if the terminal side is in quadrant 3, we are going to add the negative angle to 180 degrees. And since the given angle is negative 135, we have 180 plus negative 135 is equal to 45 degrees po. And our answer is equal to the solution presented here. Thank you for watching this video lesson. I hope that you had a great adventure as you watch and learn. God bless for everyone. Stay safe.